Hello, hello, all of you are welcome to the present video lecture series of Suresh Gyanwar University, in which today we discuss about the phase rule. Phase rule itself, the whatever we have the different phases of the materials, the substances, the matter, the compounds, the chemicals. For example, in case of the chemical calcium carbonate is the limestone, calcium oxide, that is the lime. So calcium oxide in the solid form, calcium carbonate in the solid form. Calcium carbonate undergo the reaction of heating behavior, then this is converted into the calcium oxide. So that is the solid, and as well as the carbon dioxide, which is the gaseous. So we have to see the solid, gases, liquids, whatever in between the semi-solid, amorphous, different phases and different states, physical states are there. Whatever those particular physical states are also controlled by the pressure as well as the temperature. We have to know the boiling point of water. So water having the physical state is the liquid. So water is converted into the water vapor. So that will be the physical state of that is in the form of the gases. So water vapors. We have to see the water cycle in which the water undergo the process of the vaporization. So that particular changes of the one phase to another. So what happened in this particular case? The degree of freedom which controls the process of the vaporization in the water cycle. All of you know about the water cycle, in which water itself undergo the process of heating. So heating, the temperature is increased, whereas the temperature also relates with the environmental factor, and one of that is the pressure. So what happened after heating of the continuously heating of water? Then that particular water is converted into the water vapors. So the process is the vaporization. Since this is the natural process for a human being, the sustainability of human being, that is depends on the water and water cycle. So phases. In this particular case, what happens during the heating, water is converted into water vapors. Then water vapors undergo the process of the condensation. So that is the gaseous phase of water vapors. That is the whatever the chemical formula of water is the H2O. So the different phases of H2O is the solid, that is the ice, H2O liquid, so that is the water, H2OG, it is the water vapors. So during the whole water cycle, water, one of the precious compound, one of the precious material, and that is useful for human sustainability. So therefore we can see the three phases of water. One is the liquid, that is the we are using the water. Another is the gaseous form, gaseous phase, and that is the water vapor. The third one is the ice or snow. So that is in the form of the solid. So H2O solid. Okay. So here we say that particular ice. Ice is converted into the vapor. After melting of that, this is converted into the vapor. So we say the phases. Phase of ice is solid. Phase of water is liquid. Phase of water vapor is the gases. So those three come together and we can control those uh, with the help of the degree of freedom. And those controllers are the temperature, because when we heat material, so then the phases change. But during that particular process, heating boundaries, what happen? One phase to another phase. That is the transformation. So in that particular case, if suppose we have the water and water vapors, so that is the heterogeneous condition. The point where two phases coexist. So in case of the water, the boiling point is the temperature where water vapors as well as water liquid both can coexist that particular boundary, and that can be controlled with the vapor pressure. So that is the temperature where um, both phases coexist, and that is the heterogeneous system. So therefore phase rule is also called as the heterogeneous system because of the homogeneous. So different phases are in the form of the homogeneous. Now we have to see hydrochloric acid. So hydrogen chloride gas, and this when passed into the water, so that becomes the HCl. HCl itself, the hydrochloride. Similarly, in case of the sulfuric acid, sulfur trioxide, that is in the form of the gases, plus H2O, that is the water. So then they form H2SO4, sulfuric acid. So there is the very complication. One more thing is there. All of you are well known about the alloys. What are alloys? Alloys are the mixture of two or more metals or elements. In case of the brass, all of you know about the brass, that is the beetle. So, beetle, the brass contains two metals. What are those two metals? Zinc and copper. So they also mixed with each other. So what happened in that particular case? Solid, solid, and then the form, the solid mixture, and particularly the melting point also vary in a mixture. So that is the eutectic mixture. So let's we have to see the phases, the component, the degree of freedom, and how these correlates to gives a new particular rule, and that is the phase rule. And phase rule itself was invented by the Gibbs, J.W. Gibbs, and so that's this particular phase rule is also called Gibbs phase rule. The phase rule, one name Gibbs phase rule, because J.W. Gibbs has invented this particular relationship between the phases, component, and degree of freedom. So that's why that is also called as the Gibbs phase rule. Then what happened in this particular case? The system, the phases. So here the phases heterogeneous equilibriums is there. So therefore this particular have the another third name, and that is the heterogeneous system. Phase rule, heterogeneous system, and Gibbs phase rule. So here the relationship, how we can give one component and another component automatically vary. So that is the relationship by which we can get the so many technologies. Because if suppose we want a very hard material, so that hard material can be obtained by employing the heterogeneous rule, by employing the phase rule, by which we get the certain materials which becomes, for example, in case of the stainless steel, so that is the rust proof. So in that particular case, two or more elements are added. For example, silicon, iron, so that to become whatever the stainless steel one, carbon is also added. So therefore, that particular stainless steel having the corrosion resisting property, as well as when we have the only iron, so iron undergo the process of the rusting, whereas stainless steel is not there. So that particular specific property is because of the heterogeneous system in which the one, two component or more components are there. So therefore, that is the component. So here today we discuss about whatever the today the one component system, and that is the water. In case of the water, there is the component is one. So now we have to come towards the basic chemistry. Chemistry itself, all of you know about the that is the study of chemicals, study of compounds and their particular permutations, the combinations, the reactions, the properties, the chemical properties, the physical properties. All those are related with the with this particular uh, the chemist chemical reaction. What happen when A and B mix? Then what happen? For example, if suppose we have the different explosives, for all of you well known about the dynamite. So what happen in the case of the dynamite when chemical reaction occurs? What happen in case of the petrol? So petrol are the hydrocarbon. Those chemicals in presence of oxygen undergo the reaction and they form their respective oxides, carbon dioxide and carbon monoxide. So that particular chemical reaction. So this can be explained with the help of the study of chemicals, and that is particular chemistry. Now the materials, what are those materials and substances which all over world we can see from our eyes, any of the the thing what we can see, that is the material. If suppose we have to see the calcium carbonate, that limestone. So limestone or whatever the stone, so that particular stone itself is the material. So different materials are available all over our world, and then they have the substances. And what about the article? If suppose we have the chair and table, those are the articles. In the kitchen, the different utensils are the article. For example, spoon, so that is the article. So for example, we have uh, the utensils. In case of the utensils which iron press, so that is the article. What, so that particular iron presses and we get the specific uh, specificity in the iron, and we have to get the pressed uh, clothes. So that is the articles. Similarly, if suppose we have the PVC wire, PVC cables, so those are the articles. In case of the laptop, mobile are the article. Now, the different chemicals are there. For example, PVC wire, so that is formed by the chemical. That is vinyl chloride, the polyvinyl chloride. So PVC cable, this chemical involved is the polyvinyl chloride. So that is the polymer. In case of the limestone, the chemical is the calcium carbonate. In lime, the calcium oxide. In case of the air, the different chemicals, the oxygen, the nitrogen, and other number of gases. So that is what we have, that one is the air. So air also contains the number of chemicals in our body. Whatever the proteins, carbohydrates, then they have the chemicals, glucose. So that is the those are the chemicals. So now, in case of the chemicals, further we have the two things: the organic compounds, the inorganic compounds. So whatever different phases are available, and then we have to see the organic compound. So, what are those particular organic compounds? Anyone? Those carbon and hydrogen containing compounds, and some derivatives with the oxygen, nitrogen, like that. For example, C2H6, that is the ethane. So, ethane is the organic compound, as well as C2H5OH, ethyl alcohol. So, ethyl alcohol is also the chemical. So, whatever organic chemicals ethyl alcohol. So that is in the case of the liquors and wines. So ethyl alcohol that is also used in the medical application. That is the whatever that is antiseptic. So that is so here ethyl alcohol that is the organic. In case of the petrol, the different hydrocarbons, number of hydrocarbons, number of compounds are present in a sample of the petrol, which are the 6 carbon atom, hexane, 7 carbon atom, nonate. So number of hydrocarbons, number of organic compounds are present in a petrol. Similarly, we have the primers, we have the diesel, the kerosene, even the carbohydrate, carbon, hydrogen, and oxygen. So those are the organic compound also. The glucose. So here number of organic compounds and whatever those things are present in the nature and they have the specific boiling point, specific melting point. So this is the definition. Whatever the compounds having the only definite the constant value of melting point. So for example, in case of the ethyl alcohol. So ethyl alcohol, that one having the specific boiling point, is similarly methyl alcohol having the specific boiling point. So that particular boiling point, the heterogeneous condition there, and that is called the so the relationship is called the phase rule. So here we have to see the one component. Now the inorganic compounds, all of you are well known, the calcium carbonate, calcium oxide, iron oxide, silicon oxide, alkali metal oxide, sodium oxide, potassium oxide. Now we have the metals. What are those particular metals? The lustrous material. They can easily cut down and then lustrous appears, whatever the ductility. So metals are what we have various example of metals in the periodic table. Sodium, whatever the copper, Cu, the zinc, Zn, gold, Au, number of tungsten, W, titanium, Ti. So these are the metals. But when two or more metals along with the elements, they form the alloy. So what are those alloys? The combination, the mixture of two or more metals. Even the some elements are also added. For example, plain carbon steel, where the iron, the silicon, as well as some other materials, carbon, silicon. So plain carbon steel, that is the alloy of iron, then the carbon, and then the silicon. Whatever other elements or metals may be added in case of the brass, the metal which are present in brass are the zinc and copper. So that is the brass. So brass having the combination of zinc and copper. So that is the mixture. So that is the example of the alloy. So alloy, whatever we can say the two components. For example, copper and zinc. So copper and zinc mixture, they have specific relationship and that relationship is controlled by the phase rule. Therefore, we can see the brass, bronze, steel, these are the other examples. Now we have the one component this system, here the phase rule itself. So clearly this indicates the phase rule is an important tool used for the quantitative treatment of system in equilibrium. Equilibrium. So what about the equilibrium? One, so from uh, H2O liquid and here H2O gas. So both have the same either liquid or the vapor. So that is the equilibrium. So what happened? The phase rule. This is an important tool used for the quantitative treatment of the system. So here quantitative that is related and here in the equilibrium form. So therefore we get the boiling point. It enables us to predict the condition that must be specified the system to exhibit equilibrium. It enables us to predict the condition that must be specified for a system to exhibit equilibrium. Two or more different phases are present in equilibrium to form a heterogeneous system. Such systems are studied by the page rule. So that is the heterogeneous system. For example, we have any of the liquid. So that liquid we have giving the temperature, we are heating it. So what happened? The liquid condition is converted into the vapor condition. So during that particular boundary, we have either solid or liquid. So that particular is the heterogeneous system. Homogeneous in the same phase, whatever the liquid. So whole liquid is there, but we have given the temperature heated at a specified pressure. So therefore, that will the boiling point. So here heterogeneous system occurs. So what we have, we can say that a equilibrium is so here, and this system is controlled by this phase rule. J. W. Gibbs, J. Willard Gibbs enunciated the phase rule in 1876, whatever about 101.5 century, on the basis of thermodynamics principles. So the J.W. Gibbs find out given the phase rule about 151 and a half century ago in 1876, and that was the basis of the thermodynamic principle. So what are those particular thermodynamic principles? Those we have the first rule, the second rule of thermodynamics, zeroth rule. So that is entropy. So that is the relation relatively what we have. So here this rule predicts qualitatively the effect of temperature, pressure and concentration on a heterogeneous system. So therefore we have to see the heterogeneous system, that is whatever I have discussed about the boiling point. That is also the case in the melting point. So that particular rule predicts the effect of temperature. So here we have first of all we have to see the what is the Gibbs phase rule, and this is from the mathematical expression of this phase rule. Here the F is degree of freedom and C is the number of components. So here we can see that particular uh, T is equal to the number of phases, C is the number of component, F is the degree of freedom. So here the phases, whatever we have already discussed, the solid phase, the liquid phase, the gaseous phase. Then the degree of freedom, which are the temperature, which are the pressure and the concentration of that particular system. So here concentration, for example, glucose. So glucose, 5 gram glucose is present in 100 ml of glucose solution. So therefore, here two things are there. One is the glucose and that is present in the water. So 5%. So 5% is the concentration. So here the degree of freedom, the temperature, the pressure as well as the concentration. So here the mathematical relationship of phase rule, and this phase rule indicates that F is equal to C minus P plus 2. Whatever, if suppose we have to say that number degree of freedom are correlated with the number of components, then this is subtracted by the number of phases and added the 2. So here, when we have the number of component 1, and for example, that is in the water. So in case of the water, the liquid and the phase is 1, and because that is whole water, so here is the whole concern only the relation with the water. So therefore, the number of component is 1, and the degree of freedom will be that can be calculated by the mathematical expression of phase rule. So this heterogeneous system in which the water may be towards the water vapor and water may be towards the ice. So those are the boundaries. So here, in case of the whole of water, the number of component is only water, then the phases is only one. So that phase is the liquid phase. So therefore, degree of freedom are here 1 plus 1 plus 2. So 1 minus 1 is equal to 0 and plus 2. So therefore the answer is the 2. So here we need for any of the graph, then we need the temperature and pressure. So all one component system can be completely described graphically by stating only two variables, temperature and pressure. So this one is called whatever we have the application of phase rule. We have to see one component system, and that one component system is what we have, that is the heterogeneous system, that is the water system. So we have already all of we have the sustainability of ourselves that is controlled by the water. So water is converted into water vapors. So that is relatively we have. How we can see the clothes are dried because the water in the wet cloth, so that can be evaporated. So that is the sustainability. That is our life. Now, if temperature is very little, whatever go back to the 0 degree centigrade, so what happen? The water is converted into the ice. So in a water cycle, the water vapors are converted into the water, or somewhere they can be converted into the solid. So therefore, there is the application of a phase rule in a one component. So here we have already discussed the again in a heterogeneous system in an equilibrium is not affected by the gravity or electrical and magnetic force. This one is also important because magnetic force is Earth, the electrical electromagnetic radiations, so that is the force of gravitational. So the number of degree of freedom of the system is related to the number of component and the number of phases. So therefore F is equal to C is equal to P plus 2, where we have already discussed. Now we have to come towards the one component system, and that is the well known is the water. In case of the water, so the two variables, the pressure and temperature, we can get the the curve, and this curve is specifically is the phase diagram. So here we get the different relationship between the temperature and pressure. Those two are the degree of freedom as well as the concentration is also, but is the whole is the one component. So what happened? In this particular case, the one component, the example is the water. So the curve, whatever x and y coordinate we are using, and in that particular x and y coordinate, here we are using that is the pressure and one coordinate and temperature in the another coordinate. So you can see here the different curves are obtained. So what happens in a phases? Phases are what? The solid phase, one boundary, that is whatever we can say the centrally is the oxygen, sorry, the O, that is the triple point, the B and C. So the area cover. covered by BOC, that is the solid. So that particular specific phase is the phasal area, that is the solid, and that is the ice. So ice phase itself is present in a curve boundary BOC. So therefore, O itself is the triple point where three curves can coexist. So here in case of the one component system, that is the water, we have the boiling point. So clearly it indicates that what is the boiling point. Clearly it indicates one another thing, that is the triple point. So we can see here what we have. So all of you can see that one is the 100 degrees centigrade, whatever the direction, y direction, and temperature is the 100 degrees centigrade. And here the area itself, BOC, the solid, then D, COA. So that is the area, that is the phase, the water liquid, and AOB. So that particular big area is the vapor area. So vapors and the boundary covered, whatever. So here and the water, the liquid having the COA. So this portion, water is the area of whatever the phase, the water in which the liquid phase, and this is the water, whatever we can see. Another, we can see the BOC, and this area is the solid. So here the ice itself is formed in the boundary of this, boundary of which CO and B. So that boundary specifies the solid state of water, and COA, this is the liquid state of water. So those are the water, whatever the surface water, whatever the groundwater, whatever the rainwater. Now, the when we heat the water, then water vapors are obtained. So similarly, here we have to increase the temperature from 100 degrees centigrade. Then further, definitely that will be the, so here boiling point will also be increased. So whatever that can also correlate with the vapor pressure. So all those are relatively, we can say, the example of one component where the three different curves coexist, and one, and that coexistence of three different phases. What are those three different phases? The solid, liquid, and gases. Those coexist at a certain point. So what about that certain point? Here we are mentioning the O. So three different curves meet each other at that point. So that is the triple point. Whatever all of you know about the traffic uh, organization, the road infrastructure, so where the various signals are there, and that whereas four ways are there, whereas the three ways are here. When four ways meets, so that is the word here. The concern of the triple point, where the three curves meets, and this particular triple point of water is there, and the graph clearly indicates that 0.0075 degree centigrade and 4.58 millimeter of mercury. So that is the triple point. So what happened here, all of you can see the 4.58 millimeter of mercury. One thing. So that particular 4.58 millimeter of mercury, and that is the pressure, and the temperature 0.00. So here is the triple point. What about the boiling point? That is at 1 atmospheric pressure, 100 degrees centigrade, and as well as the melting point, that is at the 0 degree centigrade. So here the three different heterogeneous system occurs. The fusion curve, where the solid and liquid coexist. This is the heterogeneous. In case of the vapor pressure curve, so there the curve, the boundaries of curve having the liquid and vapors. So there here the water liquid as well as water vapors are there. Now one more thing is there, and that is the OC curve. So regarding the OC curve, this is the sublimation curve. Here the solid state is converted into the gaseous state. So that particular system is the sublimation. So in case of the sublimation system, what we have, that is the conversion of solid into the water vapors. So that is, those are the snow. So there is difference between the snow and ice, because ice, whatever the fusion curve, the melting point curve, that is converted into the water vapor. But in case of the sublimation process, where the solid is converted into the directly gases, the iodine example. Similarly, here that particular solid state, and that is the snow. So in Kashmir, in the high mountains, whatever the case itself is the snowfall. So in this particular of the snow, whatever here you can say the sublimation curve. Sublimation curve, conversion of solid into the gases. So here the conversion of solid water. So that is the whatever here the conversion, and this particular curve is called the sublimation curve. So here three different curves are there. Whatever those curve, the first one, the melting point curve, okay. Then second one, the vapor pressure curve, and then third one, the sublimation curve. Sublimation, melting, and vaporization. Whatever that particular, the boiling. So here we have seen the one component system where we get that particular whatever the correlationship between the solid, the liquid, and vapors. So what about we get the that particular correlation between the vapors, the liquid, and as well as the solid. So that is the great concern regarding any of the material, because they are present, two or more materials are present. Even we have already discussed one component system. So there are the video lecture series in which all of you can also see the two component system, as well as there the so here you can get the triple point. So triple point where so here also that particular triple point is there. So now you can say one component system. Here we can get the OB, OA, and OC. These are the stable curve. OB. So here OA, OB itself is the sublimation curve, and OC itself is the fusion curve. Then we have the uh, O2, um, uh, O to A, and that is the vapor pressure curve. So would we have to see that phase diagram here, stable curves OB, OA, OC. Metastable curve are also there, and that is O dash area, the three AOB, COB, and AOC. So those are also present in the area. Then we have to see the triple bond. How many number of triple bonds are there? Triple points are there? One. So here we have the another concern. Water is one of the components of one component system, and in this particular case, water exists in three possible phases: ice, water, and vapors. So these three single phases may form four possible equilibrium. Whatever we have the equilibrium sets, the whatever vapor pressure, whatever we have the sublimation process. So all of these are related. Whatever the solid is converted into the liquid, and that is the melting point curve. Then the liquid is converted into the vapors, so vaporization curve. Then solid into the vapor. So that can also be seen whatever the solid and liquid pressure, those two can also be seen in the respective study material. So solid liquid, liquid water, the solid vapor. So here we get the one thing solid to liquid. So that is these can be clearly indicates in the phase one component phase diagram. So here you can say OB, what happened in case of the OC, and what curve represents the OA, and where is the metastable curve, whatever the A dash. So here we can say one more thing is there. So now the the curves study. So here it is known as the vapor pressure curve of water. The curve OA starts from point of O, and here the freezing point of water is 0.0098 degrees centigrade under 4.579 millimeter of mercury, and ends at A, the critical temperature 374 degrees centigrade and 21 atmosphere. Above critical temperature on the vapor phase exists whatever may be the value of pressure. The value of pressure of water increases, and then automatically the range in the engage in the temperature. For example, if suppose we have the nuclear power plant, in that particular case, the different water is converted into the water vapor. So water vapor, these can be controlled by application of modern technology. So here the concern of the OA. So what happened? F degree of freedom we can find out, and that degree of freedom can be find out with the help of the formula. Here F is equal to C minus P plus 2. So whatever the curve OA value of that particular curve, here F is equal to C minus P plus 2. So the correct answer itself is 1, because 1 is the component. Then the whatever and 2 are the phases at the equilibrium. So whatever the OA itself is the equilibrium. So here we can say the triple point and A. So here we get the particular. So what happened here? The answer itself is the one. So the curve OA as a melting point curve slants upward and slope may away from the temperature axis from this phase rule. The water vapor system is now one of the other the multiple choice questions which are given with respect to one component system. Okay, with respect to one component systems, what is the mixture present at the triple point? So the question is with respect to one component system. We are today discussing only about the one component system, and what is the mixture present at the triple point. So their correct answer, the water, ice and vapor. So can clearly indicates in the phase diagram. So water here at the O point they want. So this particular the correct answer itself is the D. Water, ice and vapors are present. Since at the triple point all the states of water are in equilibrium, all the three states will stay together at this point where the three phases exist. So it is in in a variant where degree of freedom is 1. Now the another multiple choice question, because these questions are also important and relevant for the purpose. Because of that we can see that particular whatever the correlation, under what condition is one component system converted to two component system. This is the question basically. What conditions one component system converts by two component system. So there is no stability of us. So decrease the temperature, add an immiscible temperature, and the final is the correct answer is the B. So what about this B, add a miscible liquid? Explanation, we know that two immiscible liquids from the heterogeneous mixture similar if miscible liquid is uh, added to the one component system, then under high temperature and pressure it can be converted into two component system. So whatever here one component system explain which of the following statement is incorrect about the triple point. The point at which the solid, liquid, and gaseous phases for a substance to coexist. The triple point exists for a substance at a specific temperature and pressure. The triple point, so this is the correct answer. The triple point exists in a single temperature and is not related with the pressure. So this is the explanation. The triple point for a pure substance occurs in between. Okay. So here the triple point for a pure substance occurs in a closed system at a particular temperature and pressure. So for example, one cannot be varied with the available uh, things. So now we have the another one more question. Urban under what condition is a two component system converted to one component? Here, add an immiscible liquid that by that particular way we get the that converted to one component system. We know that two miscible liquids uh, form a homogeneous mixture. Similarly, if an um, immiscible liquid is added to the two component and system, then under high temperature and pressure it can be resolved, it can be converted into the one component system. Now another, calculate the degree of freedom for the following reaction. This is what we have: the methane, then the carbon dioxide, then we have the water. So here CH4 is converted into CO2. What will be the answer? The degree of freedom will be 2, and so the number of components in the system is triple point, and the minimum or page in this reaction is there. Therefore, the degree of freedom is given by like that, and that is F is equal to 2. One more question: calculate the degree of freedom of decomposition of potassium permanganate. Here, the correct answer is the B. And so, what about that particular B itself? Explanation in the reaction, the number of phases is 3: solid, liquid, and gases. So, what happened? And so, therefore, the degree of freedom is given by F is equal to C plus. So, thanks for this particular presentation. We can see that is the white area that we can see that particular itself is one more. So, here all about the one component system. Thank you for all. If anyone want to ask me the question relevant with this particular phase rule, we have a great application of phase rule. However, here only one component system was expressed, but in case of the two or more um, component systems are also there. So, okay, if anyone want to inquire, want to share the knowledge, want to get the knowledge, then he or she can ask me on my mobile number, and those mobile numbers are already in the website in the faculty. So we have Swiss Canware University have the great opportunity. So all of you can join whatever the Suresh Canware University, because that is the one of the big challenge to world. Highest infrastructure is available, and whatever the different buildings, number of buildings are added. So definitely there will be uh, whatever we can say. So here, most important, relatively fire safety system where the water is to be poured over the that high temperature. So that is the concern. Let's see, we have already discussed one component system of water, various curves, sublimation curve, vapor pressure curve, that is the melting point curve, the fusion curve. So all about this, all of you are welcome to discuss anytime, whatever you can take the mail ID uh, and my mobile number from the Suresh Gyan University. So all of you are welcome. Okay, all the best. So best wishes for